Image resolution is the detail an image holds. The term applies to raster digital images, film images, and other types of images. Higher resolution means more image detail. Image resolution can be measured in various ways. Basically, resolution quantifies how close lines can be to each other and still be visibly resolved. Resolution units can be tied to physical sizes, to the overall size of a picture, or to angular subtenant. Line pairs are often used instead of lines. A line pair comprises a dark line and an adjacent light line. A line is either a dark line or a light line. A resolution 10 lines per millimeter means 5 dark lines alternating with 5 light lines, or 5 line pairs per millimeter. Photographic lens and film resolution are most often quoted in line pairs per millimeter. Resolution of digital images. The resolution of digital cameras can be described in many different ways. Pixel resolution. Resolution is the capability of the sensor to observe or measure the smallest object clearly with distinct boundaries. There is a difference between the resolution and a pixel. A pixel is actually a unit of the digital image. Resolution depends upon the size of the pixel. With a given lens setting, the smaller the size of the pixel, the higher the resolution will be and the clearer the object in the image will be. Images having smaller pixel sizes occupy more space on the disk. The term resolution is often used for a pixel count in digital imaging, even though American, Japanese, and international standards specify that it should not be so used, at least in the digital camera field. An image of n pixels height by n pixels wide can have any resolution less than n lines per picture height, or NTV lines. But when the pixel counts are referred to as resolution, the convention is to describe the pixel resolution with the set of two positive integer numbers, where the first number is the number of pixel columns and the second is the number of pixel rows, for example as 7680 by 6876. Another popular convention is to cite resolution as the total number of pixels in the image, typically given as number of megapixels, which can be calculated by multiplying pixel columns by pixel rows and dividing by 1,000,000. Other conventions include describing pixels per length unit or pixels per area unit, such as pixels per inch or per square inch. None of these pixel resolutions are true resolutions, but they are widely referred to as such. They serve as upper bounds on image resolution. According to the same standards, the number of effective pixels that an image sensor or digital camera has is the count of elementary pixel sensors that contribute to the final image, as opposed to the number of total pixels, which includes unused or light-shielded pixels around the edges. Below is an illustration of how the same image might appear at different pixel resolutions, if the pixels were poorly rendered as sharp squares. An image that is 2048 pixels in width and 1536 pixels in height has a total of 2048A, 1536 equals 3,145,728 pixels or 3.1 megapixels. One could refer to it as 2048 by 1536 or a 3.1 megapixel image. Unfortunately, the count of pixels isn't a real measure of the resolution of digital camera images, because color image sensors are typically set up to alternate color filter types over the light-sensitive individual pixel sensors. Digital images ultimately require a red, green, and blue value for each pixel to be displayed or printed, but one individual pixel in the image sensor will only supply one of those three pieces of information. The image has to be interpolated or demosaiced to produce all three colors for each output pixel. Spatial resolution. The measure of how closely lines can be resolved in an image is called spatial resolution, and it depends on properties of the system creating the image, not just the pixel resolution in pixels per inch. For practical purposes, the clarity of the image is decided by its spatial resolution, not the number of pixels in an image. In effect, spatial resolution refers to the number of independent pixel values per unit length. The spatial resolution of computer monitors is generally 72 to 100 lines per inch, corresponding to pixel resolutions of 72 to 100 ppi. With scanners, optical resolution is sometimes used to distinguish spatial resolution from the number of pixels per inch. In remote sensing, spatial resolution is typically limited by diffraction, as well as by aberrations, imperfect focus, and atmospheric distortion. The ground sample distance of an image, the pixel spacing on the Earth's surface, is typically considerably smaller than the resolvable spot size. In astronomy, one often measures spatial resolution in data points per arcsec and subtended at the point of observation, since the physical distance between objects in the image depends on their distance away, and this varies widely with the object of interest. On the other hand, in electron microscopy, line or fringe resolution refers to the minimum separation detectable between adjacent parallel lines, while point resolution instead refers to the minimum separation between adjacent points that can be both detected and interpreted, for example as adjacent columns of atoms, for instance. The former often helps one detect periodicity in specimens, while the latter is key to visualizing how individual atoms interact. In stereoscopic 3D images, spatial resolution could be defined as the spatial information recorded or captured by two viewpoints of a stereo camera. The effects of spatial resolution on overall perceived resolution of an image on a person's mind are yet not fully documented. It could be argued that such spatial resolution could add an image that then would not depend solely on pixel count or dots per inch alone, when classifying and interpreting overall resolution of a given photographic image or video frame. Spectral resolution, color images distinguish light of different spectra. Multispectral images resolve even finer differences of spectrum or wavelength than is needed to reproduce color. That is, multispectral images have higher spectral resolution than normal color images. Temporal resolution, movie cameras and high-speed cameras can resolve events at different points in time. The time resolution used for movies is usually 24 to 48 frames per second, while high-speed cameras may resolve 50 to 300 frames s, or even more. Many cameras and displays offset the color components relative to each other or mix up temporal with spatial resolution. Radiometric resolution. Radiometric resolution determines how finely a system can represent or distinguish differences of intensity, and is usually expressed as a number of levels or a number of bits, for example 8 bits or 256 levels that is typical of computer image files. The higher the radiometric resolution, the better subtle differences of intensity or reflectivity can be represented, at least in theory. In practice, the effective radiometric resolution is typically limited by the noise level, rather than by the number of bits of representation. Resolution in various media. This is a list of traditional, analog horizontal resolutions for various media. The list only includes popular formats, not rare formats, and all values are approximate, since the actual quality can vary machine to machine or tape to tape. For ease of comparison, all values are for the NTSC system. Analog and early digital, 352A, 240A video CD, 480A, 320A Betamax, VHS, Video 8, 480A, 360A Super Betamax, Amatic, 480A, 400A Betacam, 480A, 440A Betacam SP, Amatic SP, NTSC, 530A, 480A Super VHS, High 8, 570A, 480A Laserdisc, 670A, 480A Enhanced Definition Betamax, 700A, 480A Analog Broadcast. Limit, 768A, 576A Analog Broadcast Limit. Digital, 720A, 480A DVHS, DVD, Mini DV, Digital 8, Digital Betacam, 720A, 480A Widescreen DVD, 1280A, 720A DVHS, HD DVD, Blu-ray, HDV, 1440A, 1080A HDV, 1920A, 1080A HDV, AVC HD, HD DVD, Blu-ray, HD CAMSR, 1998 x 1080A 2K Flat, 2048A, 1080A 2K Digital Cinema, 4096A, 2160A 4K Digital Cinema, 7680A. 4320A UHD TV, 15360 x 8640A 16K Digital Cinema, sequences from newer films are scanned at 2000, 4000, or even 8000 columns, called 2K, 4K, and 8K, for quality visual effects editing on computers. IMAX, including IMAX HD and Omnimax, approximately 10,000A, 7,000 resolution. It is about 70 MPIX, which is currently highest resolution single-sensor digital cinema camera. Film, 35mm film is scanned for release on DVD at 1080 or 2000 lines as of 2005. The actual resolution of 35mm camera original negatives is the subject of much debate. Measured resolutions of negative film have ranged from 25 to 200 LPM, which equates to a range of 325 lines for 2perf, to over 2300 lines for 4perf shot on T-Max 100. Kodak states that 35mm film has the equivalent of 6K resolution according to a senior vice president of IMAX. A 15 perforation 70mm IMAX film negative captures at an estimated 18K, which is the equivalent of 18,000 pixels. Print, modern digital camera resolutions, medium-size camera, single, not combined one large digital sensor, 80 MPIX, starting from 2011, current as of 2013. 10,320 x 7752 or 10,380 x 7816, 81.1 MPIX, mobile phone, Nokia 808 PureView, 41 MPIX, 7728 x 5368. See also, display resolution, dots per inch, image scanner, pixel density, high dynamic range imaging, Kell factor which typically limits the number of visible lines to 0.7x of the device resolution, references. External links, Luminous Landscapes Res Demist. On why pixel count is not always a good proxy for resolution, do sensors OE outresolve lenses. On lens and sensor resolution interaction.